Hello everyone, welcome to this new video on Zephyr 7B Beta Research Paper 2 RAG. In this video, we are going to see about the in-depth explanation on Zephyr 7B Beta's paper. Followed by that, we'll see how to fine-tune Zephyr 7B Beta for a custom use case, and I'll also finally show you how to use Zephyr 7B in a RAG pipeline. So without wasting time, let's jump into the video right now. So here if you see, the Hugging Face have provided a collection which is very important for this video, where for Zephyr 7B they have this paper, they have the model, also the previous version which was alpha, they have the SFT models and then the datasets as well. So this will be very useful, but first we'll be focusing on the paper. So here I have Zephyr 7B direct distillation of LM alignment paper, which is from the Hugging Face team, Hugging Face H4 under Louis Tunstall. So here in the abstract they have said that the aim is to produce a smaller language model that is aligned to user intent. So provided a user question, the aim of this model is to align to that user's intent. Alright. And the previous researchers have said that the Distilled supervised fine-tuning method provides increase in accuracy, but it was still unaligned to the user's intent. So what they did is they created a preference data based on artificial intelligence feedback. This is from a paper known as RLAIF. Okay, so that might have served as the base for this, because in that they would have said that instead of providing preferences of human, they would have provided the preferences of GPT-4. Okay, and that has been adopted in this paper. Why it is known as distilled SAF or distilled DPO is that once you provide an output of a model to another model and you train on that, it becomes knowledge distillation. Okay, so here if you see, they have used preference data from artificial intelligence feedback, which is from the teacher model, where the outputs would be ranked, and then they have applied direct preference optimization on top of that, which becomes distilled direct preference optimization, finally resulting in a model known as Zephyr 7B. Okay, so that is a small abstract of what is there in the paper. And here if you see, there is a comparison of Zephyr 7B versus the other models, and here you can see Zephyr 7B is doing pretty good for a small model. And here you can see, right, in coding it is just falling behind all of these, but still it has outperformed Llama to 70 billion chat. And similar is the case with other also role play, reasoning, or writing, humanities, STEM. In every place it has not provided competitive performance against GPT-4, but it has competed well against all of the other models. Okay, so in introduction they would have said the same thing which is there in abstract, but in a detailed manner. And next we need to see this specific image. So what happens is, in DSFT, which is distilled supervised fine-tuning, what they do is they'll have a set of prompt, and that is provided to the LLM, and then the LLM will respond to it. Followed by that, again those would be provided again to the model, and then a different set of responses and different set of instructions would be created, by which you will have a set of conversations which is from an artificial intelligence. So that is about DSFT. Once you build that dataset, you will be training your model, which becomes your DSFT. Alright, so I hope that should make sense. And then next what they do is, next you have again a set of prompt, and here what they do is the prompt would be sent to 4 different models. Okay, so there are a variety of models which they have used, which I'll say once we are talking about UltraFeedback dataset. So those 4 models, what they will do is they will get the output, and here what happens is GPT-4 will act as the teacher model, which will try to rank the responses. Let's say there is model A, model B, model C, and model D. So now what GPT-4 will do is it will try to rank these responses, let's say as 4 1 3 2. And then what we'll do is we'll consider that this is YW and any of this would be YL. Okay, YW is the preferred response. What is the response we are expecting from the model? It becomes our YW, and what is not expected from the model becomes YL. Okay, so technically the main problem in RLHF was that human annotation was needed, and then you need to train a reward model. For reward model DPO came, but still human annotation was there, which was overcome by this method. Okay, so now that your dataset is ready, like I said, you'll select the best one as YW, and then the second best one, or rather any of the random other three. From that you'll choose one, and that becomes your YL. And based on this, you'll apply the direct preference optimization technique, which is DDPO. Okay, so now let's see about the method in which they fine-tuned. Okay, the goal of this work was to create an open source language model which will align to user intent, and here they have specified that PyT is the teacher model, and PyTheta is the student model, PySFT would be your SFT model. Okay, so these are some conventions which is needed to know, because they would have used these conventions at the later part. All right, so here they have said, right, they have a larger teacher model which is PyT. Here it will be mostly GPT-4, and student model PyTheta, which is Mistral here. Okay, and if you don't know, just letting you know, Zephyr is a fine-tuned Mistral model. Okay, so Mistral is the student model here, and they have followed the approaches of InstructGPT, which is nothing but a framework by which ChatGPT was trained. Okay, so this was the framework in which ChatGPT was even trained, but the difference was here instead of DDPO there was a reward model training step, followed by that there was RLHF step. Okay, so now coming on to DSFT, which is Distilled Supervised Fine Tuning. Here they'll start with a raw LLM, which is Mistral 7B V0.1, which is the base model here, and they'll train it to respond to user prompt. So this is how normal supervised fine tuning works. You'll have a set of instructions and set of responses, and you will fine tune a model to align to the instructions and provide the response. So that is what happens usually. But here what we do is we'll send those instructions to a teacher language model, and then it will try to give them some response, and based on those we'll again generate some instructions and other responses, and this will form a data set. Okay, so that is what is given here, right? So you can see here we can instead have the model to generate instructions and responses. We'll have these teacher language models to generate the data set basically. Okay, and then we'll train the model on those data set, which refers to distilled self supervised fine tuning. Okay, so here if you see, we have a self instruct protocol being followed here. The dataset is constructed in a self-prompting iterative manner, where what will happen is once you will have a set of prompt, you'll provide that, it will try to generate a dataset, and based on that dataset and the prompt which you had prior, again these instruction and response will be sent again to the model from which it will be sampled and refined. Okay, so here you can see, right, the teacher is used to both respond and refine the instruction based on the response. So you'll have an instruction obviously, so based on the response again it will fine tune the instruction such that it is more prior. Let's say I'm saying classify the following sentiment present in the sentence. Maybe the better instruction could be identify the human sentiment expressed in the sentence. That can be a different data set, but maybe a better one than what I said now. So that will be done by the teacher model. Okay, so once you have this dataset, you will train your model on top of this dataset in a normal fine-tuning manner, which is PyDSFT. Okay, Py, which is the model, or else we commonly refer to as policy here, and DSFT is distilled supervised fine-tuning. Okay, Next, coming on to artificial intelligence feedback through preferences, where the approach followed is UltraFeedback. So let me show UltraFeedback dataset here so that you guys will have an understanding. UltraFeedback. Kudos to those who created this, because this is such an amazing dataset which is completely open sourced. Okay, so given an instruction, for example, here it is provided to Alpaca 7b, Pythia 712b, StarChat, and Vicuna 33b. So what happens is each model will try to respond under these categories. Okay, so it will have a response and you will have GPT-4 and it will try to evaluate under these categories. Let's say helpfulness, truthfulness, honesty, verbalized calibration. In every other aspect it will try to evaluate. So here you can see, right, helpfulness, truthfulness, honesty, instruction following. For every category, GPT-4 will try to provide a rating for this, and what we will do is we'll try to take the highest rated output and then one of the other three. Okay, highest rated would be the chosen one, and then the other three, one of those would be the rejected one. So this is how the data set should be constructed. So here you can see, right, each completion will have all of these, and they have left something here which is known as overall rating. They would have provided an overall rating here. Okay, so this is an example which is provided by them, but that selection process also it's not needed for us, because Hugging Face was so generous enough to provide the dataset as well. So here you can see UltraFeedback binarized. So here they have provided by themselves on the chosen and rejected set. Okay, so here you can see there is a set of dataset in which we need to train on. So there is train prefs, test prefs, and then for SFT also it is there. But for if you want to do this from scratch, let's say you have the Mistral and you want to do this by yourself, not depend on Zephyr, you want to do something by yourself, then what you need to do is first do an SFT training on UltraChat 200k, and then that resulted model train it with UltraFeedback binarized. Okay, so I am working on a video which will come very soon. Okay, I'm working on a video to apply DPO on Mistral models. So a video will come soon, how to apply DPO on Mistral models. Okay, now coming on to AI through feedback feedback through preferences again. So just now I saw, right, showed you, right, we have UltraFeedback dataset in which there is 4 responses, out of which we'll take the highest scored response as the preferred one, lowest scored or any of the other 3 would be the rejected one. So the dataset will be like X, which is your prompt, YW the response which is having the highest score, and YL the response with the lowest score. This is how the dataset would be. It would be a triplet. Okay, and now coming on to Distilled direct preference optimization, where the step is the final one in Zephyr 7b paper, where the goal is to refine the SFT model by maximizing the likelihood of ranking the preferred responses over the dispreferred responses. So that is the main aim of direct preference optimization, which is derived from RLHF. Okay, and the past works have said that AI feedback has primarily focused on using RL methods, but here with DPO you don't need an explicit reward model working on top of proximal policy optimization method. DPO will just eliminate all of those. It will have a simple approach to directly optimize the preference of the model to the responses. Okay, so basically it will try to align the responses to human preferences, and I have made a detailed video on how DPO works and how to implement DPO also. The video is there in the channel. I'll provide the link in the description, so if you are interested you can check it out. Okay, so that is about DPO. And now they have also provided the experimental details, where in the experiment which they have performed, they have seen that the performance has matched models like Llama 34 billion, which is almost 5x its size in various NLP benchmarks. They have used transformer reinforcement learning library for fine tuning, and they have used deep speed 0 stage 3 method for training with optimized memory and increased speed, and they have also used flash attention for that. They have used Adam W optimizer with no decay, and LoRa technique has been used again. The D type in which they have worked on is bfloat 16 precision, so mixed precision, again mixed precision training. They have run on this setup at 16 A100s, for which they took around 2 to 4 hours only. So a model which outperformed Llama 2 70 billion chat in Alpaca eval, which I'll show in the later stage in this video itself, has been fine-tuned only for 2 to 4 hours. But yeah, it was a costly GPU, but yet if you have this good system, you can even create a model which will outperform Llama 2 70 billion chat. So they have also provided a GitHub if you want to check it out. I'll provide all of these links in the description so you can check it out. Okay, so they are updating the repo. It is not updated completely yet, so once it is updated, I'll try to make a video on this as well. But yeah, still it is not updated completely. Okay, so now coming on to the datasets, we have UltraFeedback, UltraChat. These are the two datasets. Both are from GPT-4. Okay, so one is from GPT 3.5 Turbo. Sorry, what happens is they have a 1.47 million multi-turn dialogues which is generated from GPT 3.5 Turbo over 30 different topics in 20 different types of text materials. So the way in which it responds, everything will differ. Okay, so what they did was they ran over all of this dataset, and it didn't give good result. Okay, so it was saying like always it was asking some question, it was having some casing issues. So they processed it, and after several filters focusing on helpfulness and removing the undesired model responses, they came up with 200k examples, which is also provided here. UltraChat 200k. They have created the SFT model on top of this. So if you want to create UltraChat SFT model, then you can use that dataset. Okay. So coming on to UltraFeedback, like I said, they have taken 64k prompts, which is provided to 4 LLMs and rated by GPT-4, and then we take the most relevant one or the most preferred one as the chosen one, and one of the other 3 as the dispreferred one. Okay, now coming on to evaluation, they have focused on 2 different benchmarks, which is MT bench and Alpaca eval, because both of these are used to evaluate the model on chat capability, and if Zephyr 7B was trained to do better chat. Okay, but it also provided very well a good response with normal datasets as well, like let's say academic performances being STEM. In that also it gave good responses. I'm not going to say about that in this section. It has been detailedly explained in results. So let me show in the results section. Now coming on to the SFT training details, they have trained it for 1 to 3 epochs, for which they use cosine learning rate scheduler, with the learning rate being 2e minus 5 and warm-up steps being 10% of the whole steps which they trained down. The batch size is 512, and they have packed the sequence with a length of 2048 tokens. As far as DPO training is concerned, the learning rate is again 5e per minus 7, and warm-up steps is still 10%. The batch size is 32, beta is 0.1, and the final Zephyr 7B model which they have provided for us is an SFT model which was trained for 1 epoch and then optimized in 3 DPO training epochs. Okay, so this is the result which they achieved. Here you can see in MT bench it has outperformed a lot of models. So you can see it has almost given the same performance of GPT 3.5 Turbo, close to Claude, and here you can see in normal models there is no one model which has beaten it. And as far as Alpaca eval is concerned, even it has outperformed ChatGPT. Okay, so that is pretty cool with Zephyr 7B. And Now in their results they have also said that DDPO, which is Distilled DPO, has improved the chat capability of the model, and it has also improved the academic performances. So here you can see Zephyr 7B among all of those models which is present here, even including Mistral 7B Instruct, which we have used it for a long time. Here you can see there is a pretty good difference among all of this. Let's say here there is Xwin LM, which is 70 billion, and Wizard LM, again it is 70 billion. This is closely performing to those 70 billion models. So here you can see 84.5 to 85, 61.44, 64.97. So it is the state of the art among the 7B models, but it has also provided great competitive performances against bigger models, let's say even 10x its size. Okay, now coming on to the question, is preference optimization necessary? It is necessary, and they have provided why it is necessary. So here you can see DDPO minus DSFT. Let's say you haven't done an SFT training on UltraChat dataset and you did the DPO model on directly on the Mistral 7B model. Okay, so the empty bench score is very low and alpaca eval is also very low, which means you should not even consider this approach. Okay, so which means it says that first level of fine tuning is very much needed. Followed by that, you can do any much DPO or any optimization techniques which is coming up. Next you have DSFT1, which is first epoch, which is 6.64 and giving an alpaca eval win rate of 85.65. With DSFT2, the performance has degraded. Again, that's why they considered the first epoch model. Once they used the first epoch model on top of that, applying DPO, it has given the state of that performance of 86.07% in alpaca eval and empty bench score being 7.00. Next, here actually what happened was, when they were doing DPO, right, they saw that there was some overfitting in the model. Okay, after one epoch of DPO training there was overfitting, but what they said was, let it overfit and it will give a great performance. So how was that? Here is the confusion matrix from the paper author itself, and here is the number of epochs and number of DPO epochs, SFT and DPO. Let me delete this. So here, with the number of DPO epochs being 1 and SFT being 1, it was giving 7.00, but the best was SFT epochs being number 1 and DPO epochs being 3. Probably even if they trained it for further, it could have increased because there is a pattern. But here also you can see there is a decrease. When you have number of SFT epochs being increased, what happened was the DPO epochs value went lower. So here you can see, right, at the third it was 7.17 with DPO 3 and SFT 2, and when you even trained it for 3 SFT, the base itself was pretty low, and then the DPO epochs, when you increase it, it became pretty less. So it is better to have SFT epochs being number with 1 epoch and DPO epochs being 3. Okay, so that is about the paper. Now coming on to how to use this model for your own custom use cases. Let's say you have some fine-tuning work, so how you can do this. Previously, if you see, I've made a video on how to fine-tune Zephyr 7B Alpha, which is for a customer support chatbot, which is a custom use case again, and it is an industry use case because customer support chatbot is something which a lot of companies prefer to have. And in this video, I've shown how to create such a bot, for which here is a script. Here you can see there is a config file, and here is a Zephyr trainer for which I've shown how to provide the model the input which is required in a specific format. Okay, there is a specific format in which the Mistral takes input, which is the input for Zephyr as well. So I have shown that, and then here you can see I've used a quantized model for fine tuning, which is GPTQ model, and then I have also shown how to attach the LoRa modules and then train on it. For detailed explanation, please watch this video. The link will be in the description. Okay, so that is about how to code it. It is a simple code, okay, and I recommend you all to check this video because I would have explained each and every bit of this code in detail in this video. Okay, now with that being said, we are done with the paper explanation and the coding part, like how to fine tune for your own custom use case with Zephyr. Okay, but you can do a lot with this base Zephyr itself, for which I'll show now in a custom RAG use case, which is information extraction. Okay, so you heard it right. We'll do invoice processing with the help of Zephyr 7B beta, which gave very good performance. Let me show that now. So here we have the VS code, and this is the output which I got. So I started with saying hey there, and it said I'm ready to help you, and then I'm asking what is the name of the client. So let me show you the invoice here for reference, not this one. Here is the seller and here is the client, and here if you see I'm asking who is the client, and here you can see the client is Calderon Duran, and the model also responded the name of the client is Calderon Duran. And then I said what is the name of the seller, and then it said Brown Johnson. Okay, till now it is going good. So I thought, okay, it is able to tell about one specific entity. Let me ask about two specific entities, tax ID of seller and client. Let's now verify that. So here you can see the client tax ID is 981947235. Is it true? So you can see the seller tax ID is 98947235, and then the client tax ID is 9968191. So yeah, it is providing the correct response, right? So I've tested with lot of things, like I asked about what was the item purchased. It was able to say one or two out of these, and it was able to say the normal things like what was the tax percentage, what was the gross worth of the model. It was able to tell all of this, and so yeah, Zephyr 7B is pretty good with information extraction as well. Okay, so I'm working on some other things as well here, where it will try to respond in a JSON output. So soon probably a video might come on that. Here is a code which involves having an ensembled retriever. So what happens is you load the model with the help of directory loader, which will have a PyPDF loader. It will try to load the PDF, and then it will try to chunk it here with the help of recursive character text splitter, with the chunk size being 100 and chunk overlap being 20. So for every 100 characters a split will happen, and then there will be a bridge of 20, which means 0 to 100, 80 to 180, something like that, it will split. Okay, so once that is done, we'll be embedding the input by using BGE model, which is the top ranked model right now in the MTEB leaderboard, which is for embedding benchmarks. So what we'll do is we'll use the FICE vector store to store these embeddings, and then what we'll do is that FICE vector store will have act as our retriever, which will work as the embedding retriever. Okay, we'll also have another retriever called BM25 retriever. So what is the purpose of having two retrievers? So embedding retriever, it will try to match with semantic informations. Let's say you have a question stating what is the ID of the tax of the client. Okay, it is not directly provided in the PDF, so it will try to see the closest one. But with the case of BM25 retriever, it will try to work very well with, let's say you are asking about what is the tax ID. So tax ID is directly present in the document, so in that case BM25 retriever works. So it is taking the best out of both situations, for which we have used ensembled retriever. Okay, and now coming on to the information extraction side, for which we have used the model being Zephyr 7B beta, and then the model type is Mistral here, and then the max new tokens is 512, temperature is 0.1, and this is not necessary actually. Let me remove this. And now what happens is the create invoice bot will be the final function to call, for which will take The first function being create custom prompt, which will take a custom prompt template from the config. So here you can see there is context and question, and it will try to provide the answer based on this prompt, where it will try to emphasize the fact that you should not provide any responses which is not relevant to the answer expected. Okay. Next we have load retriever, which will try to load the ensemble retriever, and load LLM to load the LLM from here. Okay. Finally, we'll have the create bot function, which will take all of these, which is a retrieval QA chain. So what happens is, given a query, it will try to compute the embedding of the query. It will try to get the relevant context, and it will try to re-rank it. So it will be most relevant to least relevant, all of the stuff together. Now what happens is, this will become the context, and the model will try to answer based on that. Okay. So this is how the bot core is created. And then finally, for interface, we have used Streamlit application by using Streamlit chat interface. Okay. So yeah guys, that is about this video, where we started with Zephyr paper explanation and we ended up with maybe a production use case, because if you maintain this with a Postgres, or even if you have V8 being your vector store, this is a production use case. Okay, so let's say you deployed it, this becomes a production environment use case. So we just moved from research to production. So that is about this video guys. I hope you all like this video. If you like this video, please hit the like button and share your opinions in the comment section. I'll see you all in the next video. Until then, cheers.